Hello friends, you are watching This is Awesome Videos, and today we are going to solve some past year JEE problems. Okay, so today we are going to solve some AEEE 2004 problems. So let's get started. So this is the first one. I is equal to integration of 0 to pi by 2 sine x plus cos x whole square upon square root of 1 plus sine 2x dx. Now see, by looking first time, this sum looks pretty tough, but it's very simple sum. You just need to identify a simple things. See, here you can see is 1, here you can see sine 2x. So what I do, I just write it down. 1 is equal to sine square x plus cos square x, and sine 2x is equal to 2 sine x cos x. So I have sine square x plus 2 sine x cos x plus cos square x. That means sine x plus cos x whole square, and square root of sine x plus cos x whole square, it becomes mod of sine x plus cos x. See, in the topic lecture I told you that whenever it comes to square root and square, we have to apply the mod here. So I applied mod here by just cancelling square root and square, but here no need of mod because there is sine x plus cos x, so positive value, and where there is a positive value, mod doesn't disturb us. So here more is in not our way, so we just can avoid the modulus here. So we have sin x plus cos x whole square, and the denominator we have sin x plus cos x. 1 sin x plus cos x just can cancel out, and we have 0 to pi by 2 sin x plus cos x dx. Okay, so what's the integration? Sin x integration is minus cos x plus cos x integration sin x from 0 to pi by 2. Now just apply the limits here and get the answer. So answer is 2. We know how to apply the limits. Upper limit minus lower limit. So my right answer option is option number 2. I solved this. This is a very easy problem. I solved this because uh, to you students, you get the idea how to evaluate the sum. Very easy sum, just a tricky question, we can say that. See, this is a very good sum also from AIEEE 2004. If 0 to pi x f of sin x dx is equal to a 0 to pi by 2 f of sin x dx, then what is the value of a? Now we all know that this is the very important formula, that integration from a to b f of x dx is equal to integration a to b f of a plus b minus x. That means upper plus lower minus x, and the same formula we are going to use here. How? Just a plus b, that is pi plus 0 minus x. So I just do that. I is equal to 0 to pi x f of sin x dx. So what I do a plus b minus x, so pi plus 0 minus x. So in the place of x I write down pi minus x. Okay, f of sin pi minus x, sin pi minus x, that is equal to sin x, because inside second quadrant sin x is positive, the function is pi, so function is not going to be changed. Okay, so pi minus x f of sin x dx. Now this becomes pi integration 0 to pi f of sin x minus x f of sin x dx from 0 to pi, that is I. Okay, now this I goes here, so it becomes 2i. 2i is equal to pi 0 to pi f of sin x dx. So I is equals to pi by 2 here. I can say I is equals to pi by 2 0 to pi f of sin x dx. So if I forget this, let's do one thing. Let's do one more step here. So just forget this. So 2i is equal to pi and I is equal to pi by 2 here, pi by 2 0 to pi f of sin x dx. Okay, now what we have to do, we know this formula that the limits have common multiple, then it can be multiplied here. So here we have common multiplied 1 by 2, and that can be transferred to the limits. So 1 by 2 transferred to the limits, so it becomes 0 here, and here it multiplied, then it becomes pi by 2. So we have pi 0 to pi by 2 f of sin x dx. And by comparing this equation with our question, we have a is equals to pi here. So my answer option number 2 is my right option. Okay, tricky question, but still it's easy. This is a very good question. What they say if f of x is equal to e raised to x upon 1 plus e raised to x, and I1 is equals to f of minus a integration minus a to plus a, x d x 1 minus x dx, and I2 is equal to f of minus a to f of a g of x into 1 minus x dx, then what is the value of I2 by I1? See, this is a combination of function and integration both. So what we have to do, we have limits here f of minus a to a. Now let's find out what is comes out as f of minus a to a. If I put f of minus a here, then I have e raised to minus a upon 1 plus e raised to minus a. And if I put a here, then I have e raised to a upon 1 plus e raised to a. Okay, so if I do f of minus a and f of a, I get the addition and the answer becomes 1 for me. So I have f of a plus f of minus a is equals to 1. Why I do? Because I know the formula that I have to use this formula, upper plus lower minus x. So it becomes f of a plus f of minus a. But what it becomes? It becomes 1 by this thing. F of a plus f of minus a, it becomes 1. Okay, so what I do? I just write down upper plus lower minus x. So upper plus lower, that means f of a plus f of minus a minus x, that means 1 minus x. So in the place of x, I just write down 1 minus x. G of x, in the place of x I write down 1 minus x, here also 1 minus x, so it becomes x into 1 minus x. This doesn't change because in the place of x into 1 minus x, if I write down here 1 minus x, then this thing not going to be changed. Okay, so now multiply this whole thing with 1 and then x, then this thing going to become iota 1, and this iota 1 goes here, so it becomes 2 iota 1. 2 iota 1 is equal to f of minus a to f of a 1 into g of x 1 minus x dx. Okay, now but this thing is I2. So iota 1 by iota 2, sorry, we have to find out iota by iota 1, iota 2 by iota 1, that becomes 2. So I2 by I1, it equals to 2 here. Okay, what we have to do, we have to first evaluate the function here, that it comes out f of minus a into plus f of a is equal to 1, and then we apply the integration. Okay, so this is also a good question. Now the last one, also from AIEEE 2004, this is from the area under the curve. What they say, that y is equal to mod of x minus 2 from x is equal to 1 to x is equal to 2, and the x is equal to 1 to x is equal to 3, and the x-axis. Now we all know that I told you earlier in the topic lecture and also in the all the solved problems lecture, that whenever it appears mod, you have to find out where it becomes 0. So it becomes 0 at x is equal to 2. So what I do, I just draw the graph here. Here the x is equal to 1 line, x is equal to 3, then this shaded region we have to find out. Now whenever it becomes 0, the mode becomes 0, we have to separate the limits according to that. So here we have limits from 1 to 3, but it becomes 0 at 2. So what I do, I just divide this limit in two parts, 1 to 2 and then 2 to 3. Then apply the particular sign and then integrate. Now in 1 to 2, this mode becomes negative. So I apply negative sign here. So it becomes 2 minus x. So in 1 to 2, it becomes 2 minus x. Now in 2 to 3, this becomes positive. So I apply positive sign here. So it becomes x minus 2. Now integration is very simple. It becomes 2x here minus x square by 2, x square minus 2x. Then upper limit minus lower limit. And we get the answer, that is 1. I'm not going this simple equation here. I'm just going a thing which is important to us. Okay, so this is also good sum. Always remember, whenever there is mode, just divide at the part where it becomes 0. So this is all about today's video. Thank you for watching this video, and if you like this video, don't forget to share it and hit that subscribe button.